Right, okay. So we are into relational operators. The relational operators determine the relationship that the operand has to the other. Specifically, they determine equality and ordering. Okay, equality and ordering. The relational operators are shown here. There's equals to, for equal to, not equal to, less than, greater than, equal to, and all. The outcome of these operations is a Boolean value. Okay. The relational operators are most frequently used in expressions that control the if statement and various loops. Right. Any type in Java, including integer, floating point numbers, characters, and booleans, can be compared using the equality test and the inequality test. Notice that in Java, equality is denoted with two equal signs, not one. Remember, single is for assignment. Only numeric types can be compared using the ordering operators. That is, only integer, floating, character operands may be compared to see which is greater or less than other. Okay, so only numeric types can be compared for ordering. Right. Okay. As stated, the result produced by relational operators is a Boolean value. For example, the following code fragment is perfectly valid. Okay. Right. So it generates a Boolean. In this case, the result a less than b, which is false, is stored in C. Okay, Boolean. If you are coming from C++ background, please note that the following in C++, these types of statement are very common. We put a not on an integer. Okay. In Java, these statements must be written like this. Okay. So what it is saying is in C, C++, uh, in C++, we write as int done then if not done, right? But in Java, your conditions should we compare, we cannot put not on an integer, it has to be on Boolean variables. Okay. Okay, therefore, what do you say? Therefore, um, therefore, if therefore use if done equals 0 or done not equals 0. All right. Let me save this. Right. Okay. So go. Okay, we'll see about that later. Okay. So in Java, these statements must be like this. The reason is that Java does not define true and false in the same way that C and C++ does. In C++, true is a non-zero value and false is 0. In Java, true and false are non-numeric values that do not relate to 0 or non-zero. Okay. So true and false are their own values. Therefore, to test for 0 or non-zero, you must explicitly employ one or more of the relational operators. Then we have Boolean logical operators. We have the logical AND, logical OR, then logical XOR, and then short circuit OR and short circuit AND, logical unary NOT. Okay, and assignment or assignment XOR assignment. Then you have equality and ternary. Okay, the logical Boolean operators AND or XOR operate on Boolean values in the same way that they operate on bits of an integer. Okay. The logical NOT operator inverts the Boolean state. Not true is false and not false is true. The following table shows, so we have this A or B. Okay, so it works the same. So here's a program that is almost the same as bit logic example shown earlier, but it operates on Boolean logical values instead of binary bits. Okay, so let's right. Okay, I might as well. No. Okay, so I'll create here 3 Boolean logical operators. Let's create a file called boollogic.java. Okay, first I want to alright, so I'll start with class boollogic and public static void main string args. Alright, then we declare boolean a b. Okay, then we take the or, and okay, so we have boolean a equals true, right, and boolean b equals false. Then we have boolean c equals a or b, which will be true, right. Boolean d, okay, this will be true or false equals true. Yeah, a and b, so true and false equals false. Then we have XOR boolean e equals a XOR b, so true XOR false equals true. Then we have a complex situation. Boolean f equals, we go with not a and b, and then we OR it with a and not b. Okay, let's see. So a is true, so we have false and false, which we are going to OR with true and true. So we will get true. And then finally we have G is not a. G is not a, which is not of true equals false. Okay, so let's go ahead. Do I even have to print it? Well, let's print it anyway. Okay, so I got system.out.println that a equals okay, then b equals b, equals b, then a or b equals c, then a and b equals d, and we have e a XOR b. Then we have this complex equation a naught and b and b are a and not b equals e. And then we have, oh sorry, that is f, and this is G not a, right. Okay, let's see this. Yeah, okay. Let me move on to, okay. After running the program, you will see the same logical rules apply to Boolean values just as they did to bits. As you can see from the following output, the string representation of Java Boolean values is one of the literals, values true and false. Right. Okay, then we have short circuit logical operators. Java provides two interesting Boolean operators not found in some other computer languages. These are secondary versions of Boolean and OR operators and are commonly known as short circuit logical operators. As you can see from the preceding table, the OR operator result is true when A is true no matter what B is. Resulting the AND operator is false when A is false no matter what B is. If you use and or forms rather than operator, Java will not bother to evaluate the right hand operand when the outcome of the expression can be determined by the left hand operand alone. Okay. Okay, so these are okay. So you're saying that, as you can see from the preceding table, the OR operator result is true. Okay, right. Similarly, okay. So if you use the short circuit, double pipe or double ampersand forms rather than using the pipe and ampersand forms of these operators, Java will not bother to evaluate the right hand operand, right, when the outcome of the expression can be determined by the left hand operand alone. This is very useful when the right hand operand depends on the value of the left one in order to function properly. Okay, for example, okay, this is useful when the right hand operand depends on the value of the left to function properly. For example, the following code fragment shows how you can take advantage of short circuit. Okay, so it from left to right, right. Okay, they are evaluated from left to right. Okay, so all right. Hmm. Okay, so this short circuit, short circuit, uh, circuit logical operators and okay evaluates the left uh, expression, read the next expression first and then the right. Okay, so we can go. Yeah, I have the following example that if denominator is not equal to 0 and denominator greater than 10. Okay, so it makes sure that the denominator is not 0. Okay, since short circuit form of AND is used, there is no risk of causing runtime exception when denominator is 0. Okay, in this line of code were written using single AND version of the AND, both sides would be evaluated causing a runtime expression when right. Okay. Okay, it is standard practice to use short circuit AND or in cases involving Boolean logic, leaving the simple character version exclusively for bitwise operators. Right, this is standard. Right, so usually use the short circuit versions and leave them for bitwise operations. However, there are exceptions to this rule. For example, consider the following statement. Okay. So here c equals 1 and e plus plus is less than 100. Here using a single AND ensures that the increment operator will be applied to e, okay, whether c is equal to 1 or not. Okay, so e gets incremented no matter if c is 1 or not, Okay, the formal specification for Java offers conditional and conditional or. Okay, so short circuit versions are called conditional and conditional or. Okay. The assignment operator. You have been using assignment operator since chapter 2. Now it is time to take a formal look at it. The assignment operator is a single equal sign. The assignment operator works in Java much as it does in any computer language. Okay, it is the general form, the variables equal expression. Here the type of var must be compatible with the type of expression. Okay. The assignment operator does have one interesting attribute that you may not be familiar with. It allows you to create a chain of assignments. For example, consider this. Okay, so you can chain assignments like this. All are 0. This fragment sets the value of x, y, z to 100 using a single statement. Okay. This works because equal to is an operator that yields a right hand. Okay, so this works because equal to is an operator that yields the value of the right hand. So okay, so x yields the value of y, y yields the value of z, z yields the value of 100. Thus the value of z is 100, which is then assigned to y, which is in turn assigned to x. Using a chain of assignments is an easy way to set a group of variables to a common variable. Okay, then we have the ternary operator. Java includes a special ternary operator that can replace certain types of if then else statements. Okay, this operator is question mark. It can seem somewhat confusing at first, but the question mark can be used very effectively once mastered. Right, ternary operator. It has a general form. Here expression 1 can be any expression that evaluates to a boolean value. Alright, if expression 1 is true, expression 2 is evaluated, otherwise expression 3 is evaluated. Which is just how you would have it. The result of the ternary operation is that the expression is that of the expression evaluated. Both expression 2 and expression 3 are required to return the same or compatible type, which can't be void. Alright. So here is an example of the way that employee ratio equals to no. If denominator equals 0, then ratio 0 is num over. Okay, when Java evaluates the assignment expression, it first looks at the expression to the left of the question mark. If denominator equals 0, then the expression between the question mark and the colon will be evaluated and used. If denominator is not 0, then the expression after the colon is evaluated and used for the entire expression. Okay. The result produced by a question mark is then assignment of ratio. Okay, so there we have ternary value. Okay, so we can create MD for it's a ternary operator. Ternary operator. Okay, and let's create a file called ternary.java. Okay, so we have demonstrates so we have a class ternary public static void main string args. Okay, so we have two variables and I comma k, and then we set I equals 10. We are making the absolute value function. Get absolute value. If I is less than 0, then return minus of I, else. Okay. So k equals, if I is less than 0, then return negative of I, which would make it positive, otherwise return I. Okay, so gets the absolute value. Get the absolute value. Then we print, okay, absolute value of I is k. Okay. Here we go. System dot print line, system dot out dot print line, absolute value of I is k, and then we set I to -10, and then we evaluate again. So let's just copy and paste this, and we should have it. Okay, so okay, my bad, forgot the concatenation. Okay, so your absolute value of 10 is 10, absolute value of -10 is also 10. Alright. Okay, then we move. Okay, operator precedence. The table 4.1 shows the order of precedence for Java operators from highest to lowest. Okay. Operators in the same row are equal in precedence. In binary operations, the order of evaluation is left to right. Okay. Although they are technically okay, so operators in same row are equal in precedence. In binary operations, the order of evaluation is left to right except for assignment, which evaluates right to left. Right? Assignments evaluates right to left. Okay. Although they are technically separators, square brackets, parentheses, and dot can also act like operators. In capacity, they would in that capacity they would have the highest precedence. Okay. Also notice the arrow operator. It is used in lambda expression, but I don't understand. Okay, there we go. Okay. Precedence. Okay, using parentheses. Parentheses raise the precedence of the operations that are inside them. Alright, so this is often necessary to obtain the result that you desire. For example, A left shift B plus 3. Okay, so addition is first, right? Addition has more precedence than right shift. Therefore, this expression first adds 3 to B and then shifts A by that result, right? So that expression can be written as A right shift parenthesis B plus 3 parenthesis close. Okay. However, if you want the first shift, okay, then add 3, then it is equivalent to that. In addition to altering the normal precedence of an operator, parentheses can sometimes be used to clarify the meaning of an expression. Okay, for example, for anyone reading your code, a complicated expression can be difficult to understand. Adding redundant but clarifying parentheses to complex expression can help prevent confusion later. Right. Another point One other point, parentheses, redundant or not, do not degrade the performance of a program. Therefore, adding parentheses to reduce ambiguity does not negatively affect your program. Okay, so you should, of course, you should add parentheses. Okay, then we move on to chapter 5, control statements. A programming language uses control statements to cause the flow of execution to advance and branch based on changes to the state of a program. Java's program control statement can be put into following categories: selection, iteration, and jump. Okay, there are three types of control statements. Selection statements allows a program to choose different paths of execution based upon outcome of an expression or the state of a variable. Iteration statements enable program execution to repeat one or more statements. That is iteration statement from loops. Jump statements allow a program to execute in non-linear fashion. Okay. Okay, Java selection statement. Java supports two selection statements, if and switch. These statements allows you to control the flow of a program's execution based upon conditions known only during runtime. Okay. You will be pleasantly surprised by the power of flexibility contained. Okay. These statements allow you to control the flow of a program's execution based upon conditions known only during runtime. Okay, so it won't optimize. Oh, of course, how can I know the value of variable if it changes? Right, okay. If the if statement was introduced in chapter 2, it is examined in detail here. Okay. The if statement is Java's conditional branch statement. It can be used to route program execution through two different paths: if and then else. Here each statement may be there will be if condition statement 1, then else condition statement 2. Here each statement may be a single statement or a compound statement enclosed in curly brackets, that is a block. Okay, the condition is any expression that returns a boolean value. The else clause is optional. The if works like this: if condition is true, then statement 1 is executed, otherwise statement 2, if it exists, is executed. In no case will both statement be executed. Okay. So most often the expression used to control the if will involve relational operators. However, this is not technically necessary. It is possible to control the if using a boolean variable shown here. Okay. So we can boolean data available. If data available, then we process data, else we wait for more data. Okay. Remember, only one statement can appear directly after the if or else. If you want to include more statements, you'll need to create a block with curly brackets. Okay. Then here both statements within the if block will execute if bytes available is greater than 0. Some programmers find it convenient to include the curly braces when using if, even when there is only one statement in clause. This makes it easy to add another statement. At a later date. Hold up. Let me just. Alright, let's continue. Okay, when there is only one statement. This makes it easy to add another statement at later date. You don't have to worry about forgetting the braces. In fact, forgetting to define a block when one is needed is a common cause of error. For example, okay, so what we have to is intended to be executed. Okay, so we didn't define our block. It seems clear the statement byte available to be executed inside the clause because indentation level. However, as you recall, whitespace is insignificant to Java and there is no way for compiler to know what was intended. This code will compile without complaint, but it will behave incorrectly. Okay. Nested ifs. A nested if okay, a nested if is an if statement that is the target of another if or else. Again, nested ifs are very common in programming. When you nest ifs, the main thing to remember is that an else statement always refers to the nearest if statement that is within the same block. Okay. So else statement always refers to the nearest within that block. Same block as the else, and that is not already associated with an else. Okay. So we have else associated with this else. This is to here. Okay. As a comment indicate the final else here. Right. The else if ladder. A common programming construct that is based upon sequence of nested ifs is the if else if ladder. If else if ladder. Okay. The if statements are executed from top to down. As soon as one of the conditions controlling the if is true, the statement associated with the if is executed and the rest of the ladder is bypassed. If none of the condition is true, then the final else statement will be executed. Okay. The final else acts as a default condition, that is, if all the other condition test fails, then the else statement is performed. If there is no final else, then all the other conditions are false and then no action will take place. Here's a program that uses if else. Okay. Then we have a switch with strings, dude. Then you have a for loop. Heading over multi-dimensional arrays. Okay, so let's demonstrate the if else. Let's make a new directory of chapter 5. What is this? Control statements. Okay. Control statements. Then say make a new directory called, I should call it if else if on dash. Okay, let's create a new class if else dot. So this demonstrates if else if statement. if else if statements. Okay, then we have a class else public static void main string args. Okay, then I've created a month and a string seasons. Okay, I've created alright, so we have a month equals 4, which is April, and then we have a string season. Okay, then we check. Okay, then we check if month equals 12 or month equals 1 or month equals 2. We will say that season equals winter, right? Then I have another wait, okay, 4 seasons. Then if month is 3, 4 or 5, then it is spring. Month is 3, 4 or 5, then it is spring. Then if it is 6, 7 or 8, it is summer, right? 6, 6, 7, 8, this guy is summer. And then if it is 9, 10, 11, 9, 10, 11, it is autumn. I figured, right? Autumn. Yeah. Okay. So then we have else. So okay. Then we have else if. We put a else if in the okay else if, and then finally I have else, which says that season equals bogus month. I'm just making it up right now. Okay. So then we go system.out.println April is in the, we define which season? Season. Run it. Oh, sorry. Okay. So I want to cd. Oh. Yeah. Okay. Yeah, I want to move. Let's say for left 2, 1. Yes. Okay. Okay, and I want. That's right. Okay, so I want to remove this. Nope. Did I say I think I always save the changes, so I'll just open this here. Let's run it. April is in the spring. Okay, you might want to experiment with this program before moving on, as you will find no matter what the value given, one and only one assignment statement within the ladder will be executed. Okay, then we move on to the switch. The switch statement is Java's multi-way branch. It provides an easy way to dispatch execution to different parts of a code based on the value of an expression. Okay, so this is called Java's multi-way branch. It provides an easy way to dispatch execution to different parts of a code based on the value of an expression. As such, it often provides a better alternative than large if-else-if statements. Okay. Statement switch, expression, case, value 1, and statement break and then default. Okay. For versions of Java prior to JDK expression, JDK 7 expression must be resolved to type byte shortened char or an enumeration. Okay. Beginning with JDK 7 expression can also be type string. So we can also put on string. Each value specified in the case statement must be unique constant expression such as literal value. Duplicate case values are not allowed. The type of each value must be compatible with the type of the expression. Okay. So we have the switch statement works like this. The value of the expression is compared with each of the values in the case statement. If a match is found, the code sequence following the case statement is executed. If none of the constant matches the value of the expression, then the default statement is executed. However, the default statement is optional. If no cases and no default is present, then no further action is taken. Okay, right. The break statement is used inside the switch to terminate a statement sequence. When a break statement is encountered, execution branches to the first line of code that follows the entire switch statement. This has the effect of jumping out of the switch. Okay, here's a simple example that uses a switch statement. Sample switch. Print I. I is greater than 3. Okay. So as you can see, each time through the loop, the statement associated with the case constant matches I. All other are bypassed. After I greater than 3, no case statement matches, so the default statement is executed. Okay. Right. The break statement is optional. If you omit the break execution, execution will continue into the next case. Okay. It is sometimes desirable to have multiple cases without break statement between them. Okay, so I'll start with this is if else. Selection statements. Okay. So I first close this. Boolean logic operators. Okay. Control statements. And first we have selection. Okay. Selection statements. If else if selection statement. Okay. Ternary operator, Boolean logic operator, bitwise operators. Right, okay. So into if then I also want to create called missing break .java. Okay, so go in a switch, break statements are optional. Okay. So I'll go with in a switch, break statements are optional. You go class missing break, then we have public static void main string. Then we create a switch. Let's create a equals to 0, I less than 12, and I plus plus. Then you put a switch on I, and we define case 0 0 1 0 1 2 3 4 1 2 1 2 3 4 4 2 1, and then within the we write system dot out dot println I is less than 5, and then we break here. The next series of cases, I is less than 10, less than 5, and greater than equal to, okay. Anyways, 7 8 9, so we have 9 8 7 6. System dot out dot I is less than 10. Then we break, and finally then we have case, then you have a default case, right? We go system I is 10 or greater. Then break at the last is optional because here we have a default case. Okay, so when I run this, you say I is less than 5 is less than 10 or greater. Okay, so as you can see, the execution falls through each case until a break statement or the end of the switch is reached. Okay, while the preceding example is of course contrived for the sake of illustration, omitting the break statement has many practical applications in real world programs. To sample it more realistic usage, consider the following rewrite of the season example shown earlier. This version uses a switch to provide a more efficient implementation. Okay, so we have a new class, switch.java. We have improved version of the season program. And we have a class switch. Public static void string args month equals 4, and then also we have a string season. Okay. Then we put a switch on month, and then we define the cases 1, 2, 3. Okay, so we have cases 12, 1 and 2, which corresponds to, we set season equals winter, right? And then we break the statement. Then we have case 3, 4 and 5. 4 and 5, we would say season equals spring, and then we break. Then we have case 6, 7 and 8. We would say season equals summer. We have case 9, 10 and 11. Okay, so we have season equals autumn. And then we put a break, and then finally we describe the default case. This season equals August month, and at the end of the switch we print system dot out April is in the season. There we go. April is in the spring. Okay. So as mentioned, the beginning with JDK 7, you can use a string to control a switch statement. For example, we put strings here. Okay, the string switch. The string contained in str, which is true in the program, is tested against the case constants. When a match is found, in case a code sequence is associated with that sequence is executed. Being able to use strings in a switch statement streamlines many situations. For example, using a string-based switch is an improvement over many equivalent sequences of if-else statements. However, switching on strings can be more expensive than switching on integers. Therefore, it is best to switch on strings only in cases in which the controlling data is already in the string form. In other words, don't use strings in a switch unnecessarily. Okay. So basically, don't use a string in a switch unnecessarily because it has performance effects. Okay. Alright, Sashi, we call it a day today. Alright.